All right, so now we're actually on B. I'll move the cone out of the way so we don't get a shadow. We're going to talk about cylinders, and I thought it would be fun to start out.
Cones?
Oh, sorry. I thought it'd be fun to start talking about pyramids first. Our old pyramids. What was special about these pyramids? I guess these ones might be better.
Well, you can fold them up into a cube.
How? Show me how.
So you can do it sort of like this.
And what does that mean about the volume of a pyramid?
Well, it should be 1/3 of maybe a cube.
Okay. So for a pyramid, we get 1/3 a cube for these pyramids. Okay. And what's the volume of a cube?
A cube is just
Length, width, height.
Okay.
Yeah.
Is there any sort of base times height analogy here?
well, you have the base and the height.
Okay.
And a cone is sort of like a pyramid,
Cone is sort of like a pyramid.
except with a circular base.
Yeah. I'm going to have a hard time drawing it. Unfortunately, we didn't have any cones laying around the house. So talk about some of the similarities and some of the differences
Well,
with pyramids and cones.
the only real straight edges you have on a cone is the height
Uh-huh.
and where you draw the lines to the base.
Okay.
Well,
But you're still really stacking things on top of each other.
except the circles are centered and the squares are not.
Well, I mean, this is a cone.
Interesting. Interesting. For a pyramid, do you think it matters where the top is?
Well, no, because you can have it anywhere and it'll still be a pyramid. I've seen some centered pyramids.
Yeah. And it turns out for a pyramid that formula works. When it's centered like that, it's not going to be, you're not going to be able to make 3 of them into a cube. But the formula would still be 1/3 base times height.
Interesting.
And so, do you think the same type of formula is going to work for a cone? Do you think they're similar enough to pyramids?
Yeah,
Oh yeah.
because the way you find the volume is still similar because you're still like stacking circles.
Except
You're stacking circles. What were we stacking here?
squares.
Square.
Or you could stack rectangles.
So
Kind
rectangle.
of similar to a cylinder because you were stacking circles, except this time the circles are getting smaller.
Aha, yeah. And what was getting smaller here?
The squares.
The squares were getting smaller. And they got smaller in a real specific way. They went to 0.
0.
And it
At
goes
some
to 0
point.
here.
Goes to 0 there.
Because they're pretty similar.
So what do you think? What do you think
So,
the formula?
I think
for-
it would be 1/3 area of base times height.
Okay. So that's going to be 1/3.
Third pi r squared.
Oops, 1/3 pi r squared times height. Now I'm going to show you an interesting thing that happens when the height of our cylinder and the height of a cone is equal to the radius. Okay.
Okay.